for taking the time to listen to my talk today, and I'll get started. So first of all, welcome. I recently was working on a very sophisticated application, and it's one of the most sophisticated I've ever been a part of. A key feature of this application took a very complex input, in this case a large production database connected to a CMS, and fed almost all of that data into a big Ruby function consisting of over 150 lines of raw SQL, and transformed all that data into a thousands of line long CSV file, too long to be read by a human, that went straight into a machine representing every possible permutation of the data. So this was a very complex system. Now, given that I was one of the original authors of the code, you might think that it was really easy after some time had passed to just jump right back in. Well, that was not exactly my initial experience, and in support of this, I cite something known as Eagleton's law. Any code of your own that you haven't looked at for 6 or more months might as well have been written by someone else. I think the idea behind this quote is that old code is challenging, and after a certain amount of time, it doesn't really matter who wrote it. We call this legacy code, and many of us deal with it every day. For those who haven't yet experienced this, I'd like to talk about some of the hallmarks of a legacy code base. One of the hallmarks is old interfaces. For this application, the version of Ruby and Ruby on Rails we were using were both aging. If you looked at the libraries we were including, which are gems in the Ruby community, they were forked. Many of them were unmaintained, and many of them, had no path to upgrade. And each of these presents unique obstacles to development. The second thing you'll see is vulnerabilities. Because you're not updating the software, you're not getting the latest security patches, and your software is vulnerable. And a third thing you'll see is dead code. There's poor cleanup over time, and that leads to code that never ever gets called. There's a saying, you aren't going to need it. Well, that wasn't followed in the development process, and instead we tried to add everything at once. And our code is reliant on abandoned design patterns and known anti-patterns. So if these are some of the downsides of a legacy code base, I'd like to talk about some of the upsides. And the two big ones for me are profit and users. First of all, for profit, a legacy application is very often an application that is making somebody some money. And if you're a developer on a team with this type of application, the fact that you're there implies that money is somehow being made. And you'll have users who care about your product. They've invested in it, and that contract between your application and those users is very special. So we have a survey question that should be available to you now, and when that's finished, we'll take a moment and look at the results.
All right, Jake, we have the results, and it's a pretty even split between some and a lot at 46% for some, 43% a lot, only 7% said none, and 4% said it's all I do.
Thank you very much, Bill. So legacy code is definitely a part of many people who are listening today and their journey working with applications. That's really great information. Thank you for participating. So one thing I know is that developing legacy code is inevitable. And I mean this kind of in two ways. It's inevitable for you. Many applications are entering this phase of the life cycle today. And as a developer or project manager, this is something that you will be a part of your career. It's also inevitable for the applications themselves. No application is really ever feature complete as long as it exists we're going to want to keep adding features to it. Development will continue. And when that happens, we hopefully have tests. We hope we have them, and in the case of the application I was working on, we did, with test coverage and design that we still liked down the road. But what happens if we don't? Well, now we have something much worse, and that is untested legacy code. If you're going to keep developing in a language like Ruby, for instance, and you don't want to break existing features, you're going to have to add tests, or those features will break. There's three types of tests that most of us are familiar with: unit test, API test, and user interface tests. Unit tests test individual functions and classes within the application. API tests test the way that different parts of the application talk to each other and interact with third parties. And user interface tests test the way that people behave when using the site. So if we needed to start from scratch testing a legacy code base, are these three tools enough? Well, they each have their own individual shortcomings. For unit tests and API tests, there are potentially thousands of functions, and we need to know which ones are actually used. For user interface tests, we need to know what a user actually does on the site. Figuring out which types of tests to write is pretty hard and subjective, and they all have their own unique blind spots. I have a metaphor that I'd like to introduce that is going to be a part of my talk going forward, and that is a unique type of application that can be represented by taking a watermelon, throwing it into a fan, and the fan chops it up and splatters it onto a wall. If you can indulge me for a second, I'll explain. So we start off with a watermelon, and that is that complex input, the large production database I mentioned. We take the watermelon and we throw it as fast as we can into a fan. In this metaphor, the fan is represented by that Ruby and SQL function. It chops up all of the data, and then it is outputted in a splatter onto the wall. And that is our 5,000 to 10,000 line CSV file representing every possible permutation of the data. Now, there's an interesting feature of a system like this, and that is that changes to the fan are very hard to detect. If I take a watermelon and I throw it through the fan today, and then I take a different watermelon and throw it through the fan tomorrow, and I compare the splatter on the wall, it's almost impossible to tell if the fan has changed in any way. But detecting changes are what the users actually care about. We have to be able to guarantee consistent output, which leads me to a question. Are any of the traditional types of tests, unit test, API test, and user interface tests, equipped to cover this feature? Well, the closest is a unit test, but the problem is that the test database can never rival the complexity of a production database. But we have to test because we must keep developing while also preserving behavior. So this is a problem. And what do we do? I have a solution, and it's something I've built in production called a gold master test. As I said at the top, my name is Jake Worth, and I'm a developer at Hashrocket in Chicago. This talk is going to be about 40 minutes and 62 slides in total. So I work mostly with Ruby, JavaScript, and Elixir, but this talk is not about a specific technology. It's about a testing tool that I believe can be useful in any technology stack. My examples in code today are going to be Ruby, and if that's not your language of choice, please bear with me. I think Ruby is a very good language for these types of demonstrations because it's readable and pretty not surprising. So let's get started. My agenda. Today I'm going to talk about defining the gold master test. Then we'll move into writing the test, and finally we will look at working with the test. So first, defining the gold master test. I'm going to start by talking about a test that is like a gold master test, and then use that in comparison to explain what a gold master test is. And at this time, I think we can get started with our second survey.
Okay, well, it sounds like you've got a rapt audience here because about 70% are not familiar with this testing technique. 23% have heard about it, and 9% have written one before.
Okay, that's great. Thank you very much again, Bill. It's nice to be talking to people about something that is kind of new. So, the genesis of this idea came from a book that was published in 2005 by Michael C. Feathers called Working Effectively with Legacy Code. In the preface to this book, Feathers defines legacy code as code without tests, and this perfectly fits our working definition of legacy code. He sums up a key idea in the book with the following quote: "In nearly every legacy system, what the system does is more important than what it's supposed to do. So the behavior isn't right or wrong. In fact, those terms don't really have any meaning here. Instead, it simply is what it is, and it has that contract with the user." This comes from a subchapter of the book about a type of test known as a characterization test. And here's that definition. A characterization test is a test that characterizes the actual behavior of a piece of code. It isn't right or wrong, it simply exists, and what it does is important. In order to describe how we use a characterization test, Feathers introduces something he calls a characterization test process. And here are those steps. Step 1, use a piece of code in a test harness. Step 2, write an assertion that you know will fail. Step 3, let the failure tell you what the behavior is. And lastly, step 4, change the test so that it expects the behavior the code produces. I'm going to show a little code now in Ruby and the test framework RSpec. Again, if these aren't your tools, I hope that it will be clear what I'm trying to convey. So here we have an example. We expect something to equal 2. When we run the test, it fails. It says I expected 2, but I got 1. Then we simply update the test to say expect something to equal 1. Run the test again, and it passes. I've certainly written a test or two this way, and I'm willing to bet a few people on the call have as well. And in any other context, it's kind of a lazy way to write a test because you're completely avoiding all the upfront work of understanding what the code is supposed to do. But if you accept the premise that all that matters is what it actually does, then it makes perfect sense. Feathers gives us a heuristic to explain when such a test is applicable. So here's the heuristic for writing characterization test, and it's abridged by me. Step 1, write the test where you will make changes. Write as many cases as you feel you need. Look at the specific things you're going to change and attempt to write tests for those. And finally, write additional tests on a case-by-case basis. So here's how this idea, the characterization test, differs from the Gold Master test. The characterization test focuses on areas where you will make changes, you can see in the first bullet. It cares about things on the micro level, the specific things that you're going to change. And Feathers states that these are not black box tests. We can see how the code actually works, and in fact, we're encouraged to figure out how it works. A Gold Master test is the opposite of all these things because it focuses on the entire application. It only cares about the macro level. And a Gold Master test is ignorant to what is happening inside the black box. So with all that in mind, here is my definition of a Gold Master test. A Gold Master test is a regression test for complex, untested systems that asserts a consistent macro-level behavior. The image on the right is one of the Voyager Golden Records, which was launched into space in 1977 to show the universe the sounds we've recorded up to that point on Earth. So let me break down the definition here. A regression test, meaning we have behavior that we like and we don't want it to go away. We want to preserve the behavior. That asserts a consistent macro-level behavior. The application works in the most broad possible sense of the word, and we want it to continue working. So let's look at a sample workflow for this type of test. On the first run, we restore a production database into our test database. On the second run, second step of the first run, we run the Goldmaster test. We capture the output, and then we end the first run by ignoring the output. So with following along our metaphor, restoring the production database, that is the watermelon. Running the Goldmaster test is the fan. Capturing the output is the splatter on the wall. The first run's kind of boring. The second run is where things get more interesting. On subsequent runs, we restore the production database into the test database. We run the Goldmaster test, we capture the output, we compare it to previous output, and if it fails, we change the code, or we commit the new output as the new Goldmaster. Any kind of failure prompts a decision. The ideal application for this type of test is mature. It has behavior that exists that we like and we want to preserve. It is complex, so complex that a few unit tests and an integration test are not going to be enough. And it's an application where we expect minimal change. We expect minimal change to the output. Users are expecting a certain thing to happen time and time again. A few of the benefits of this type of test. The first is that we get rigorous development standards. This is a very high bar for your developers. You're basically saying nothing in the application changes at all. And this gets into a virtuous development cycle where the test is passing and passing and passing, and then it fails, and that prompts a decision. It can expose surprising behavior. If you're using code that is not deterministic or otherwise flickery in behavior, a Goldmaster test is going to catch it much more quickly than any other type of test. And it's useful for forensic analysis. If you're looking at why something broke, you can use a tool such as, if you're using Git, for instance, you can use Git bisect. Because now you have a very high definition of what the application does. You can travel back in time and figure out when something broke. So once again, my definition of a Goldmaster test is a Goldmaster test is a regression test for complex, untested systems that asserts a consistent macro-level behavior. So now that we have a working definition of a Goldmaster test, let's take a look at writing one. Part 2, writing the test. For this part of the talk, we'll be looking at some more Ruby and RSpec and a little bit of SQL. First, I'd like to go back to the feature I started talking about. So we have a large production database, that's the watermelon, fed into a complex PostgreSQL function, that's our fan, output into a giant CSV file, that is the watermelon splattering onto the wall. And this application is pretty much the perfect candidate for a Goldmaster test for the reasons we've already discussed. There are 3 phases to writing the test: preparation, testing, and evaluation. So first, the preparation. This is where we build that rich, complex watermelon. And the way that we do this is we have to get a production database dump. The first thing you do when you get that data is you have to scrub it of sensitive information. Emails, IP addresses, session information, passwords, financial information, etc. And this is very, very important because some version of that database is going to be included with your project and checked into version control. So you need to be very vigilant about what kind of data that you're leaving to pass on to the test. My recommendation for this is restoring the production database dump into a local utility database and then running a prepared SQL script against it. This makes it very repeatable, and you'll be able to do it more quickly in the future. So once we have the scrub data, we need to dump it out as plain text SQL. And we wrote a small rake task, which is the make utility for Ruby to handle this. So here's what that looks like. It's called createdb.rake. And so we name our task with the symbol createdb. Then we list a destination, and this is just going to be a file called gold_master.sql. Then we shell out to the pgdump utility. We name our sanitized utility database. We pass a couple of Postgres flags, and then we send all that to our destination. Note the PG flags. That's kind of a hand wave here because those flags are going to be very unique to your database of choice and the configuration of your database. But just know that dumping a production database into a test database is going to require some data massaging that will be unique to you. And at the end of the talk, I'll post a link to GitHub that's actually in the talk itself where you can see an example of these flags that worked for us. So now our preparation phase is complete, and we move into the second phase, which is the actual test. So when I write a test, I like to start with an empty file to validate setup, and I think this will help us get a little familiar with our spec as well. So here's a test. It's called gold_master_spec.rb. So we describe the thing we're testing. In this case, it's a module called fan and a function called shred, and that is the actual thing that we're examining today. And all we say is that it produces a consistent result. So stepping into the test, the first step is to dump the production database into the test database, and here's how we do that. We're using application record, which is active record for people pre-Rails 5, but that's our ORM that we're using, and we start a transaction. We declare a here doc called SQL, and the first thing we do is we truncate the schema migrations table. That is something we have found to be necessary. It's pretty much a guaranteed collision between the production database and the test database. Once that's complete, we simply read the goldmaster.sql file, and if you've prepared the file correctly, that is going to dump all your production database into the test database. Now, this is a richer testing environment than almost anyone has ever experienced. You have the entire production database at your disposal in the test. Next, we need to perform the actual transformation. So we call our function. We call fan.shred, and that represents the fan chopping up the watermelon. Now, shred is written in such a way that it returns something valuable, in this case, our CSV output. We're going to assign that to our variable called actual. And you have to write shred in a way that that actually works so that you can make comparisons against it. So now we have to make assertions about what actual is. And here's my strategy for doing that. The strategy I like to employ is that the test can actually do two things. On the first run, it can generate the gold master. And on subsequent runs, it can compare the current result to the checked-in gold master. And this is a very literal interpretation of that flowchart from a few slides ago. The test can actually do both things. And this is a personal preference. I would rather that the test can be run on the first run without the developer having any information about what a gold master test is, even though it'll only really happen one time. So, going further on down our test, it works on the first pass, and here's how it works. We name a file called our gold master file, which is that gold_master.txt. On the first test run, we check to see if the file exists, and if it does not exist, then we simply write our actual to that file. And this is going to pass on the first run in Ruby because that save will return true, and it's kind of a no-op, but we generated the file. If we look at the second pass, so on the second pass, the test file does exist. In that case, we read the file, and we compare the gold master to the actual. If they don't match, then we write the file again. And this adds unstaged changes to your version control, which is a side effect that I like and we'll talk about in a second. Finally, we say that we expect actual to equal gold master. And if the two things do not match, then the test will fail. Here is the entire test file for those who may be looking at the video or want to check it out later. It's just 19 lines. Okay, so then we move into the evaluation. On a stable system, this test should pass most of the time. And if it fails, that means that we broke the contract we have with the user. If it does fail, then we've written a new version of the gold master file which is going to be apparent in your version control, and you're going to have to address it. So how do we address that situation? So if we have a test failure, we look at it and we say, is this a valid change? If it is a valid change, then we check in the new gold master. We have a new gold master and we just proceed. If it is not a valid change, then we need to pause and reevaluate. We have to make a decision before going forward. So now that we know what it's like to write a test, I'd like to talk for a minute about what it's like to work with an application that has this type of test in the code base. Part 3, working with the test. So I'd like to look at a sample workflow for a developer with this test in their suite, and then talk a little bit about some more advanced applications. So to start, we'll look at a real-world example. This is Today I Learned, an open source project that we maintain at Hashrocket. And it's something that I helped build a few years ago to help my coworkers write small blog posts about things that we learn every day. You can check it out at til.hashrocket.com. So the posts are ordered by the newest, which gives us an always refreshing feed like most social media sites. The post that you're looking at was the newest post when I took this screenshot. And this encourages my coworkers to keep generating content because it's ideal to have your post be in the top position. So let's say that I wanted to write a gold master test for this application. Well, first of all, is that even a good idea? Well, first of all, Today I Learned, is it mature? Yes, it is almost 3 years old, and in the world of web development, that's pretty old. It is complex. The application itself, despite a pretty simple looking veneer, is actually pretty complex. It's written in Ruby and Ruby on Rails, both very complex tools, and then all of that is sitting on top of the entire internet, which is inarguably a very complex system. So in my mind, yes, Today I Learned is definitely complex. And we definitely expect minimal change to the output. People have been coming to the site for almost 3 years. They expect it to behave a certain way. And my coworkers who use it every day also expect consistent behavior. So I want to make an assertion that a gold master test might be able to prove. This is my assertion. The home page, given the same data, should not change without us knowing why. I give the home page the exact same database, and I go to and I visit the actual home page. It should not change without us knowing why. And on GitHub, in the HRTIL repo, that's the Today I Learned repo, I have a branch called Gold Master Demo, which demonstrates the test I'm about to show. So looking at our preparation once again, first we need to get a production database dump. Then we need to scrub it of sensitive information. We dump that data as plain text SQL, and then we check in the SQL. This is my scrub script. For those who might be interested, it's called sanitize_production.sql. I touched 3 tables in the database: developers, autumn sessions, and posts. Developers doesn't have a lot of sensitive information, but as an exercise, I decided to sanitize it anyway. So I changed username, email, Twitter handle, admin, and Slack name to unique but innocuous pieces of data. We use a library called Autumn for our session management. That information is both irrelevant and I probably shouldn't check it into an open source project, so I delete that entire table. And then we limit the posts. I want to delete from posts where the ID is greater than 200. There's about 1,300 posts today, and that will bring it down to 200. And that is purely data massaging for performance, and it's a compromise. I'm going to get a faster test because I'm inserting less records into the test database. But it's a less perfect representation of the production database. But I've been maintaining this application for a while, and I know that this application doesn't care if any of the posts are greater than 50, which is the pagination breakpoint. So as far as Today I Learned is concerned, 51 posts is the same as 50,000 posts. You have to make those types of calls based off of your familiarity with the code base. So to write this test, we're going to take almost the exact same path that we took on the application I started with today. We will start a transaction, we will truncate our schema migrations table, and then we will read our goldmaster.sql file, again dumping the entire production database with a small bit of data massaging into the test database. So we have the watermelon from the metaphor. Next, we're going to use the capybara function's visit to visit the root path, which in Ruby on Rails is an alias for the posts controller index action, which lists all those posts. And this kicks off a very complicated series of events that brings all of those posts into the browser of the person who is viewing the website. So post controller index action. Next, we need to say something about what happens there. So we're going to use Capybara's page.html function, and that is going to take all the HTML off the current page and assign it to a variable called page_HTML. This is the splatter of the watermelon, the thing that we actually care about. So now that we have all the HTML from that page, we're going to work through a similar conditional to the previous example to determine whether the gold master is changed. And here is that entire test file. It is about the same length as the previous one. If any HTML on the page changes in any way, this test is going to fail, and it's going to fail loudly. So I'd like to take a minute now and look at an example of a developer with this type of test in their code base. Okay, so what we have here is a video of myself working in Vim and Tmux on the Today I Learned repo. And it's just like live coding, except I recorded it in the past, so I know that I can't make a mistake. So let me orient everybody to the screen here. In the upper left, we have the terminal. In the lower left, we are watching the spec fixtures directory where the gold master is going to live. So every 2 seconds, that's going to show us the contents of that directory. Right now, there is no gold master. There's only the gold master SQL file. And on the right is the test that we're actually going to run. So the first thing that we do is we run the test one time. And this should generate our gold master test file. Okay, so the test passed, and we can see in the spec fixtures directory there's now a file called gold_master.txt in the lower left. If we run it again, assuming that the code is deterministic, this should pass on the second pass, and that file should not change. So we can see that the test passed and the same timestamp is on the file, so it was not changed. At this point, we want to check in that gold_master.txt file because that is the gold master that everything is going to be compared against. So we'll check in that file. So at this point, I would want to change behavior on that page in a way that I think the gold master test would catch. There's lots of ways that I could change the home page. I could change meta tags or HTML or many different things, but I think something that would be interesting would be to change the controller action itself because I think it's a little bit sneakier and more realistic. So if we go to the controller in question, so this is the post controller, and if you look on line 25, there's that index action that renders the post onto the page. We assign a variable called post. We preload some things on line 26. We limit them to a scope called published. And then on line 28 is where we're actually ordering the posts. So we're ordering them by published at descending. Let's say that a new developer comes out of the team and says, I would rather order these posts by likes instead of when they were published at. Well, that's a pretty easy thing to change. So we'll just change what we're ordering by to likes instead of published at. So I would think that this is going to break the goalmaster test, and we'll run it one time and see. Okay, so the test failed, and it failed very loudly. You can change the way that this output is prepared to make it nicer to read, but you can see that the test failed and the timestamp changed on the goalmaster text file. So we broke the goalmaster test. Well, big deal, we broke the goalmaster test. This should probably have broken other tests. This code base was developed in a TDD way. We have like 106 examples. And the test coverage, according to code coverage tools, is between 95 and 100%. This should not be the only test that breaks by this change. So to determine if that's true, we're going to run the entire test suite. For the sake of the exercise, we'll need to restore our test file, our goldmaster, to its original state, and we'll run all the tests. So we're going to run our integration test suite and our unit test suite and see what happens. Okay, so as you can see, we ran 107 examples, and only one test failed, the goalmaster test. As I said, 107 examples, 95 to 100% test coverage, and it didn't matter. Only one test caught this massive change to the way that the homepage renders. So it's good that the test caught it, but does it actually matter from a user's perspective? Well, this is what the homepage looks like if we let that change get into production. Instead of the post that was at the top, we now have a post that was published on July 15, 2015. It was written before we had good syntax highlighting, so it doesn't look as pretty perhaps as some of the other posts. If somebody came to this application today, they would think, based off of what they already know about Today I Learned, that nothing has been published in 2 years, and that would break our contract with the user. So it actually does matter. This is an example of a goalmaster test in practice. There are a few challenges to this type of test. The number one is maintenance. Anytime that the schema for the database changes, you're going to want to acquire a production database dump, regenerate your SQL file, and run the test. And to that, I would say that this is an investment. Sometimes this is the only kind of test you have time to write or are able to write for your test suite. And it's an investment in the maintenance and longevity of your application. The second challenge is it's probably a little slower than other types of integration tests, but as I mentioned, we can optimize the data and massage it. And thirdly, I think it can be said that it implies correctness. People might look at this and say, well, this is what it does, that means that that is good. We know now that that's not the case. And this is an opportunity to teach your team about what characterization tests and goalmaster tests are all about. On to a few future plans. So I'm thinking about a type of test for Today I Learned that does what this test did, only uses a screenshot. The shortcoming with the example I showed was that it only captures HTML. So if CSS has changed at all, or any of the fonts that we've downloaded have changed, or JavaScript has done anything weird on the page, it's pretty unlikely that that test is going to catch it. So a future plan that I have is a test that takes a screenshot of the homepage and uses a Capybara function save screenshot using the image magic library to create a diff between those two images. And here's what that could look like. So this is a screenshot of a failing test case. Everything in green is a change from a previous test run to the current test run. So what actually created all this green? Well, the only thing I did differently was I removed the Google font from the meta tags. A very small change that someone might actually do by accident. Because we weren't loading our Google font, the browser defaulted to whatever font it wanted to put in there, and it made a substantial change that affected the header, the post, the stuff on the left. It's a pretty dramatic change, something that you wouldn't catch in a more traditional test. So to wrap up, if you have a mature, complex, and stable application, consider goalmaster testing. It can simulate a much larger test suite And from my experience, just writing the test is going to tell you some surprising things. A slightly broader conclusion is that applications of the future are going to require creative testing strategies. In my world, Ruby on Rails, a lot of applications are becoming legacy, and they have to continue to evolve, regardless of whether they have the test coverage that I might like. New frameworks and ideas are coming that are going to continue to push the boundaries of what a test can be. That's what I came here to be with you to talk about today, and I'd love to talk more, perhaps offline and in the Q&A with people who share that passion. Before I go, I'd like to say...
Go ahead.
Oh, thank you, Bill. I'd just like to say thank you to Sauce Labs for bringing me here today, to my teammates at Hashrocket for helping me develop this test, and to everyone listening today for your attention. And I'll turn it over to Bill.
That's terrific. I can imagine this presentation on stage live where you actually bring a watermelon and a fan. I'd like to see that. We do have a few questions, so and I think they were covered a bit during your presentation, but it might help to reinforce. Again, one of them is, what type of systems are suitable for this test approach? For which systems would you not recommend this kind of Golden Master test?
Well, I think to answer that question, I would say the application needs to have the correct testing tooling. If you're in a newer technology stack, at which I am in some of my side projects, you're not going to necessarily have the tooling to make these types of assertions. Ruby on Rails is a great example to use because it's now a mature enterprise framework, and there's lots and lots of test tools to choose from, and Ruby is still kind of new in the world of web development. So anything prior to that should be very, very good for this type of test. It really comes down to the tooling and what you're able to say about a test and what you're able to assert. But even newer frameworks such as Phoenix, the MVC framework for Elixir, I found that you're able to write this type of test. So in my opinion, the application of it is pretty much unlimited.
Okay, this sounds like a follow-on question where automating legacy systems is quite a challenge due to the flakiness of the resulting tests. What would your approach be toward test automation of legacy systems that don't quite adhere to good software principles?
That's a great question. Flakiness, and on my team we call them test flickers, is one of the hardest challenges of writing an automated test. And I would encourage those people to start with something like a Gold Master test or a characterization test. So this is something I've advocated on several projects recently on my team. The non-deterministic stuff. So if you're calling something if you're calling for something to be in a certain order, well, that can be different based off of whether the developer is running the test on a Mac or on a Linux machine or a Windows machine. That order can be different. That type of non-determinism is something that can sneak into the code base when you don't have a test like this. This type of test specifically exists to find and identify those types of problems. So if you set a test like this up and run it on, have your Windows developers run it and then have your Mac and your Linux developers run it, you're going to find that type of flakiness, and it's going to help you actually drill down and solve the problems rather than just not knowing if they exist at all. So that's definitely, that's why we write tests, is to find behavior that is not consistent and make it consistent so that no matter what you do, the test will continue to pass and the application will continue to act the same way over and over again.
All right. One question here is it's kind of a behavior or a change in terms of how do you reinforce this? How do you impact the rest of the team or to get everyone on the team behind this kind of approach?
As far as selling your team on it, this test is a little bit unconventional, and anytime you're proposing anything unconventional, you're going to have to probably change some minds. I hope that the part of my talk where I describe the ideal application will resonate for people with this conundrum, because an application that has that criteria is going to kind of be screaming for a test like this, because you're not going to actually be able to cover it with the traditional types of tests. The application that I wrote this test for had a lot of tests already, but if we were going to actually try to cover everything that CSV function did, it's almost impossible to do. So I would say first, let the need drive the test. Don't try to force this test onto a code base that doesn't need it. And secondly, I think that just discussing the options and education, like perhaps maybe covering it at a lunch and learn or a show and tell that you might have internally, or some kind of like book club where you read books like Working Effectively with Legacy Code by Michael C. Feathers, would help make the team understand the value of a type of test like this. And of course, in the end, you can just write the test and add it to your test suite, in which case, that's more of a brute force approach. But if it's there and it fails, that's going to prompt a discussion as well. Kind of a joke, but I think that depending on the size of your team, you might actually be able to do something like that and get some value out of it.
Interesting. I think you touched upon this when you had discussed the trade-off with Today I Learned, and the fact that you would limit the SQL database to posts fewer than 200. But we do have a question here that's, how much time does it take to get a SQL file generated for an application which is coming from a huge database? I guess that probably is the trade-off that you had mentioned.
Right. So when we wrote the test I talked about in the beginning, it was pretty quick. Now I know some people deal with data on a scale that's way larger than what I was probably working with. Everybody has their own unique needs. The thing about generating that goldmaster.sql file is that you're not doing it a lot. So if it takes a minute, and that's pretty extreme, but if it takes a minute to generate, that's a cost that your developers are only paying. They're only paying when the time that they generate it. It's not happening on every test run. As far as the comparison goes, the comparison of the Goldmaster to the current test run, I would definitely advise some sort of data massaging if you find yourself in that kind of situation, because you need to balance the efficiency. You need to balance the effectiveness of the test with its efficiency. And if the test takes 5 minutes to run, someone's going to take it out of your code base, and it's not going to be part of your suite. So you have to find a balance. And the only thing I can suggest for that is knowing your application well, trying to understand it well, and figuring out areas where you can limit the data that you put in there.
Oh, very good. This is prompting more questions. One is, well, do you have any tools that you use to help push the quality as a team effort with the gold standard test? Sure.
As far as specific testing tools, we're in the Ruby land most of the time, so we're pretty partial to RSpec. I think that having a test-first mentality or having a test at some point mentality is more of a cultural thing than a tooling concern. At Hashrocket, testing is very, very near and dear to our hearts, and it's like a very important part of our process. A lot of that is because as a consultancy, when we finish building an application, we hand it off to our client, or if they may or may not have a client development team, and that's sometimes the last that we see it for a long time or ever. So having really good tests is important to guarantee that our work is going to stand up over the long haul. But I think the tool that I used today for Ruby was RSpec, and I used that instead of another very popular tool called Cucumber. My logic there is that RSpec is a very declarative test framework. You can see what everything does, and I can read through it. And hopefully the non-Rubyist on the call today could get like a sense of what I was doing. Whereas with a test suite like Cucumber that's more abstracted, it's harder to see that, and it's less likely people are actually going to read through the code and try to make sense of what it does. They're just going to say, this test always fails, let's get rid of it. So I think using a declarative test framework is something I advocate in general, but for a test like this is extra important so that it's really clear what's happening, and people, even if you write the test and you leave the team, other developers will see it and maybe be able to make sense of what you were doing.
Got it. And I think you also made mention of the approach that you take at Hashrocket, which is test-driven development, or TDD. So we've got time for one more, and that comes to ask, can a gold master test be used without database interaction, or without a database interaction?
That's an interesting question. I'm trying to think of how that could be possible. If you were testing something that didn't rely on the database, I suppose, so let's say you were doing something in a functional language, such as Elixir or Clojure, you could test the function itself by purely generating your own inputs that don't come out of a database with some kind of struct, and then you could test how that functional function works just by what you put in and what comes out of it, and that could possibly be a way of not using the database. I think the core value of the test, though, is that you're creating a situation that is much more complex than a test database. If anyone writes a lot of tests here, you probably use fixtures or factories where you put like one or two users into the database, and one or two locations and one or two rentals or something, and you have five records in the database. And once you get to production, you realize that is a very watered down version of what the world actually looks like. So yes, I think you could do it without a database interaction, but I think that the database is the real value of the test, because you're putting yourself in this rich world where everything exists, more complexity than you could ever generate through fixtures or factories.
Got it. Okay, I know we have we're coming to the close, but I did want to sneak one more in there, and that is, do you see the Gold Master test as a separate level in the testing pyramid?
Testing pyramid is a really great question. So for those who aren't familiar, you can picture a pyramid, and at the top of the pyramid, the very smallest part is UI test, user interface test. In the middle is those API tests, and at the bottom is the unit test. And this is supposed to prescribe how much time, it's supposed to prescribe how the percentage of the test in your test suite. So you should have a very small amount of user interface tests, a medium amount of API tests, and a very large amount of unit tests, because the unit tests are the cheapest to write and the fastest to run. The user interface tests are the most expensive to write and the slowest to run. So as far as performance goes, I would probably say this test is closer to a user interface test, especially with the example I gave with Today I Learned. You're actually visiting a page, and you are using JavaScript to say what is there. But on the first example I gave, I'd say it's closer to a unit test, because you're testing one function that happens to put out a very large CSV file. So as far as performance goes, I'd say this test is more towards the top of the pyramid. You shouldn't have many of these. You should have one, maybe two, no less than five, no more than five, because it's going to be slower than other tests. But as far as what it represents and what it behaves like, it's kind of all over the test pyramid.
Okay, very good. Well, again, Jake, I want to thank you very much. I'll put one thing into your ear here regarding the using Gold Master Test without a database interaction. Mike writes possibly XML-based Java object serialization. Might be worth a blog post after we have a chance to chew on it a bit. But thank you. Thank everyone for joining us today. We will be sending out an email the next day or two with a link to the recording and the slides. And if you have any questions, please forward them to hello@saucelabs.com, and we'll make sure that Jake gets them. With that, we'll wish everyone a good day, and see you on the internet.